In this final video of this series, I'm going to show how our model CPU runs a program. So here's a program we're going to run with our model CPU. On the left hand side we've got the assembly language, and on the right hand side we've got the machine code. So on the right hand side, this is how the program's stored in RAM. The first part of the machine code program tells us what instruction we're going to do. We've got 4 instructions here. We've got move, which is instruction 1, load A, which is instruction 2, load B, instruction 3, and add is instruction 4. Some of the commands, the move and the load commands, have got parameters with them. So what we're saying here with move 15 to 128, we're saying move the value 15 into memory address 128, and then move the value 5 into memory address 129. LDA is load address register A. So LDA 128 is load address register A with the value in memory location 128. And LDB is load address register B. So this is load address register B with the value in memory location 129. And then finally we have our add instruction, which is going to add together what's in address register A and address register B. So how we're going to do this is we have a ROM chip, and the ROM chip will contain the control word settings. So if we take a look at how we will execute this program, our first instruction, move 15 to 128, this is a control table for the move command. So here we have the micro instructions, and here we have the control table that we want to execute. So the first 2 commands is the fetch cycle of the fetch execute cycle. So the first 2 micro instructions are always the same for whatever command we're running. So the first micro instruction is the program counter out and address register in. So the program counter keeps track of where we are in the program. So this will move that into the address register, and the next line will take the RAM out and load it into the instruction register, and then we'll enable the program counter to count on. Now for move, the next thing we want to do is take the program counter and address the next memory location to get the first operand for the move command, and then we'll move that from RAM into the A register. So that's RAM out, address register in. Then we'll get the next operand by program counter out, address register in, and then we'll take RAM out and move it into the B register and just move the program counter on. And then we'll so we've loaded the value 128 into the A register and 15 into the B register. We then take the A register out, which is the value 128, put it into the address register. So now we're addressing memory location 128. And then we'll take what's in B register and put it into RAM. So we'll take the 15 and put it into RAM at address register 128. We did the same thing for the other move command, only this time we're using the value 5 and putting it into address 129. For the load A, the first 2 commands are the same, the fetch part of the cycle, so address register in and program counter out, and then RAM out into the instruction register and count on the program counter. Because we're loading A, first we take the value of RAM, address register in, program counter out, and then we take RAM out and put it into A. That gives us the value 128. So we've loaded the 128 operand into the address register A, but now we need to take address register out, A register out, sorry, and address register in, and then take RAM out and A in. So we take what's in the value 128 and load it into the A register. For load B, we do exactly the same thing, except this time instead of using the A register, we use a B register. And then our add command, what I've done for that, the first two is a fetch cycle, and then we do the ALU, which is, because subtract is switched off, the ALU is already adding the A and B register, and we move it into the output register. And then for this, I'm just doing clock halt, so the program stops running. So now let's watch this running in our model CPU. Okay, so I'll just point out a few changes that I've made to the model CPU from the last video. I've added the ROM chip. The input to the ROM chips are the instruction register, which is which instruction we're currently running, and the micro instruction counter values. So the ROM chip can give us the control word depending on which instruction we're running and which micro instruction we're on. And also the flags register is going into the ROM chip. So if we were doing a conditional, something like a branch if equal, or a jump if not 0, then the ROM chip could change its behavior depending on the value of the flags register. Now the ROM chip feeds into the control word, so I've taken out the switches for the control word. That's all going to be controlled from the ROM chip now. And I've also added a reset circuit where I'm resetting, but this is all of the register inputs and the micro instruction counter reset, so that when I have a switch at the top where I can switch this circuit on, which will feed through these OR gates and feed all of the values that I want to reset. So now we'll run our program. Okay, so here's our CPU. At the bottom here I've got a close-up of the control word, and over here on the left I've got the micro instructions that we want to execute. So the first micro instruction, or the first two, is the fetch cycle, which is program counter out and address register in. So here we take the contents of the program counter, which is currently 0, and load it into the address register. So we won't see a change when we send the clock. The next instruction is RAM out, instruction register in, and program counter enable. So we'll count 1 on the program counter. We'll take the RAM out, which is the instruction. So this is the first instruction, and load it into the instruction register. So we send the clock pulse and we load 1 into the instruction register. Next one is address register in, program counter out. So we're going to now load the operand. So we load 1 into the address register from the program counter. There's 1 in the address register there. Now we'll take RAM out and load it into the A register. So we'll take the value which is at 1, which is 1 to 8, and load it into the A register. There we have 1 to 8 in the A register. Next thing is we'll fetch the next operand and we'll put that into the B register. So that's the next 3 steps: RAM out, program counter enable, address register in, and B in, RAM out, and program counter enable again. So the next 3 micro instructions, we load the value 15 into register B, and then we go A out and address register in. So we take 128, load it into the address register, and then B out and RAM in. So we'll take the value 15 and load it into address 128. Now we're at the start of the next instruction. So we do the same again. This time we'll take 5 and load it into 129. So the first 2 instructions will load the instruction register with the move command, which is 1. And then we'll take the 129 value and put it into register A. There's 129 in A. Then we'll take the 5 value and load it into register B. And then we take register A and put it in the address register, and take the 5 and put it in RAM. Okay, so the next command is load the value at 1 to 8 into register A. So first we do the fetch cycle, where we load the command into the instruction register. This time the command is 2. So load 2 into the instruction register. Then we do address register in, program counter out. So we're loading the operand now into the A register. The operand is 128. It loads into the A register. And then we take A out and put it into the address register. We take the contents of RAM from out of RAM and into the A register. So we'll load the value at 1 to 8 that we put in there before, that was 15, into register A. Now register A has 15. Now we'll do the same thing, load B with the value 129, that should be 129 there. So first we fetch the instruction. And the instruction is 3. So we load 3 into the instruction register. And then we'll load register B with the value 129. Then we'll take that 129, put it in the address register, and take the contents of memory at 129 and put it into B, which we put that in there before, that was 5. And then our final command, add 4. So the first 2 steps again are the fetch cycle, where we take address register in, program counter out. We fetch from memory the instruction, which is 4, so we have 4 in the instruction register, and then we do ALU out, output register in. And that takes the value and puts it in the output register, and finally we do a clock halt. So now the clock is frozen, and we can see in the output register we have the value 16 plus 4, which is 20. So we've added our 2 numbers together. Okay, so what we've done there then, we put the value 15 into memory address 1 to 8 and the value 5 into 129. We've then loaded the 15 into address register A and the value 5 into address register B and added them together and got the value 20. Obviously CPUs are much more complicated than this one in this model. Usually you'd have many more registers, you'd have data registers, address registers, and then you'd have things like stacks. You'd have more complicated ALU that can do logical tasks as well as multiplication and this sort of thing. You'd have more flags in your flags register, and you'd have a much bigger instruction set than just 4 different instructions, and much more RAM. But hopefully this video series has given you an idea about how a CPU works and how it's built from the logic gates. So I hope you've enjoyed the series. I'm going to go on to do some programming tutorials next. So if you'd like to have a look at some of that, then subscribe to my channel, and thanks for watching. If you'd like to download this software and have a play with it yourself, you can do it from this web address. There's also links to all the videos in the series, so you could go back over them if you want to. If you've got any questions about how any of this works, then leave it in the comments below and I'll do my best to answer. Thanks for watching.